streaming? Looks like the chat bot might be stuck. Oh, there it is. All right. Yes, we're live. Hello, hello. So I'm just gonna pick this up right where we left off last night. I was trying to get through the last world in this Robot Odyssey playthrough, which is sort of half let's play and half play testing. Because I have a little project to kind of make a port of this game. I ported the DOS version to WebAssembly, and that's what we've been playing. So I want to play through it just to make sure it works, but I'm also using this footage to make a Let's Play video, and because there aren't very many Let's Plays, and I don't think there are any of this version of the game, or at least the DOS version that I started with in this port, so. Alright, well, welcome. Welcome to the stream, folks. Let's see if I can actually remember to push the right camera. I think we might even be able to get Tuco here. Let's see, the camera is off. The gimbal has trouble starting up by itself sometimes. The lens gets stuck up against one of the motor mounts, so I have to kind of bring it over here. This is off topic for the Let's Play, but stream fans will recognize this cat camera that we've been working on. So I have to kind of nudge it a little bit, and then apply power to the gimbal, and then it starts up. And then I can pilot it. So Tuco is over there on my desk chair, so let's hover over there. I'm getting a little bit better at flying this thing, but it still needs a lot of software work that I've been procrastinating. So I apologize, it's still kind of a wobbly experience. Oh, I'm operating on 3 winches right now. Not that there's a problem, but just that they're, one of the cords had gone slack. So here we go. Take up my slack and actually look at Tuco. Hey boy. So yeah, that's my weird cat, aka Tuco, aka the co-star of the stream. So, let's see. Just catching up on chat here. Yeah, it looks like looks like I still had the chat actually open from yesterday, so it had some of the stuff from the end of last stream. Let's just reload all these windows. Alright, so I've been rambling a bunch at the beginning of these streams, just like giving an introduction. I'm gonna try not to do that all the time, but just really briefly, this is an old game. Basically imagine like Atari 2600 adventure style graphics and gameplay, but with a digital logic simulator. And that's basically Robot Odyssey. If you've heard of Gertrude's Secrets or Rocky's Boots, these are all kind of part of the same series. Robot Odyssey is sort of the latest one and the last one in the series, basically, as far as I know. And it was a pretty sprawling, adventure-y sort of circumstance, known for being pretty difficult. And so I've got this port that I've been working on, and we've had previous streams that went into the code here. I'm not going to go into the code, but the actual port tool here is open source, and so basically you combine this source code, which is mine, with the original binaries, which you can bring yourself, and it gives you a WebAssembly file. But since this game is basically abandoned and there's no one you can buy it from or anything, I just like threw it up on robotodyssey.online temporarily. If we can ever find out like who owns this, or like if anybody complains, like I'll take it down, or like they can host it or something. But like For the moment, it doesn't seem like anyone cares or is actively doing anything with the rights to this game, so I've got that. And then there's the separate open source project, which is actually just the add-on that's like all like MIT licensed, and you can stick that onto the original files to build this site. So that's what we're doing. And we've had some previous streams that went through playthroughs, and I've been posting my save game just on the Twitter account each time. So this is where we were. So this is the last puzzle in the game. And you have to press the starter button. So I'm this little human character. You have to press the starter button and then have the robots press the buttons in sequence. And it's actually fairly picky about it. You have to get on the button and then off the button, and then the robot has to get on the next button and off the next button. So you can't stay on the buttons. The order has to be correct. You can't press a button twice. I think the point I was getting up to was clock cycle 7. I've been calling these clock cycles because that's how I've been programming it. And then the way I've been initiating it is that I'll use the remote control. So you do have a couple of ways of sending signals remotely to robots. So the robots can send each other signals with the antennae. You can't send a signal as a human, but like you could program one of the robots to send a signal to a different robot. That's how I'm keeping them all synchronized. I have one robot acting as a clock generator, just so that it's easier to sync them up with a slow clock, since I don't have enough circuitry to build a slow clock in each robot currently. And what else? So I've just got the circuits wired to be reset just as is. Earlier in this process, I was resetting them using a bumper, which is more typically what I do. So I'd use a bumper on the robot that I wouldn't otherwise be using, hold that up against the wall, run the robots for a tick, and then let the circuit reset. But this time, it's getting complicated enough that I have the robots moving around and hitting, like I think most of the robots are hitting at least 3 of the bumpers. Like the top 2 robots, which are simpler, I think I could use the bottom bumper for reset, but the bottom 2 robots are going to end up hitting all their bumpers as they go through this process. So I don't want them, oh hey Duke. Uh-oh. So I don't want, don't want them at any point in this process to reset and then start over, because that would be bad if the puzzle isn't completely done. Let's come back over here. Oh, why is that line still so slack? The software is still lacking a lot in the tension control department. There we go. It's also easier to control the tension if I just move the robot slower. Hey, nice to see everybody in chat. Nice to see you, Piotr. Nice to see you, Carrick and Tino. Oh, we've got greetings from Russia in YouTube chat. Hello. Sorry, I still don't know how to read Cyrillic, so I can't pronounce your name, but I appreciate the greetings. And hi from Funky Squid and Loremaster Noja in Twitch chat, so it's cool. Nice to see everyone. Actually, maybe that was just Funky Squid. Maybe the other chat was from yesterday. I think I might have failed to reload some of my windows. Anyway, I might have unnecessarily said hi to people. Oh well. Anyway, so this circuit, let's just run this and I can show you where we are. Basically, I've got this thing set up just so, and it's difficult to reset, so I've just been going back to the save if it doesn't work. So we'll try it, then I'll revert to the save, and we can try it again after some modifications. So to start this, if I press the remote, the robots will just start doing their thing the way they're programmed. So I need to first hit the starter, and then immediately after hitting the starter, I'll hit the remote, basically. So, like that. So we got 1, 2, 3, 4, 5, 6. Oh, and then that's where it fails, because it hits 7 twice, because there's a bug in that circuit. So let's slow that down and look at it more slowly. Alright, so back to the autosave from before I started. Let's slow this down to quarter speed. Is that going to be too slow? I need to make keyboard shortcuts for the speed controls. That is really close to not being working, not working, but it's, there's just like barely enough of a gap for those buttons not to overlap. So like we're fine up until 5. The circuit is so messy, like I just want to redo it because it's terrible, but it's so close. So I'm tempted just to keep hacking it. Okay, so yeah, it's just that left thruster on checkers needs to shut off. It's just, I don't know why it's still on, but let's investigate that. It makes an autosave after every group of user actions. So like if you do a bunch of stuff and then stop really briefly, that's where it makes an autosave. Then you can navigate them with the browser history. Okay, full speed. Okay, so let's, oh gosh, this is so messy. We're not using these are just extra sensors. And I don't think I care about that bumper. I don't know, man. Everything's been timing based for the most part. If that's not connected to the bumper, that's connected to the antenna. It would be interesting to have a patch for the rendering on this game that just gives you a little bit more resolution to see the wiring in the schematics without actually changing the gameplay. There's a remake of this game, an open source remake in Java called Droid Quest, and its wiring looks a little bit like that. It uses very thin, high-resolution wires, but still uses kind of original resolution-inspired sprites and gameplay, I think. Oh yeah, I love you too, cat. Oh gosh, I love this boy. Just feels so good every time I wake up next to my best friend. You know, it's like humans are nice too. There's certainly humans I appreciate a lot. But, you know, this guy is easily within my top 3 humans. Or, you know, top 3 creatures. I feel like there's not really that much distinction between humans and most animals. You know, it's like some animals are, you know, like hard to relate to or like hard to kind of see the familiar complexities in. But I think most animals I find really relatable, and I find it strange when people assume that animals and humans are so different. Or, you know, humans and other animals. Yeah, top 3 mammals. That's about right. Although I like non-mammal creatures too. Like, I don't know. Like, I don't personally have any bird friends at the moment, but I have friends with some really awesome bird friends. I think snakes and lizards are pretty cool too. Although I've never really known them closely. And spiders. I used to have fish, but I had a hard time relating to the fish. I was also a much different person and much younger when I had fish though, so like maybe I would relate to the fish better nowadays. Aw, cool, Funky Squid's got a nice lizard. That sounds great. Oh my gosh, Tuco is so good. Let's see if we can analyze this circuit. So yeah, it's kind of hard to see what's going on here, but it looks like that right. I keep getting confused between whether I want to call the thrusters based on what side of the screen the thruster is on or what direction the robot moves in. I feel like this game prepares you for so many of the unglamorous parts of low-level computer engineering, like always getting things confused with each other for minor reasons, not knowing what to call things, having to count clock cycles, having to sort through massive, badly engineered piles of wiring. Yeah, I mean, I don't know. I never actually beat this game as a kid, but it made a big impression on me, and it'll be nice to actually have finished it this time. Yeah, these parts are gonna get edited out, and then I'll put this up on YouTube, where I'm only concentrating on the less off-topic parts of the stream, probably, just so that it isn't so long. But this cat seems to be really into attention right now. I might keep some of the cat stuff in. I'll keep some like brief edits of the cat. Cat's looking at the birds outside. Oh, there's a crow right there on... I was about to say the water pipe, but I hope that's not a water pipe. What kind of pipe is that? I don't know, man. Some of the wiring here, I probably don't want to know. It's probably an electrical conduit. That's probably utilities for the building next door. But whatever. Crow sitting on the pipe. That's like my favorite noise that he makes. You're my favorite little hunter. Oh, I can feel his purr all the way up here. Yeah. Okay, I could pet cats all day. Oh man, the world sure is complicated, but there's still nothing much better than being nice to cats, I think. Can we get the camera in any closer? The computer vision does a pretty good job of framing if you're looking at the raw video feed, but it doesn't know about the way I have it cropped on these overlays. So really the computer vision bot should know what OBS scene I'm on for the broadcast and adjust its cropping. Oh, I could actually already do that with the current WebSockets API. It would just be more code to write. Hey, Tuco. Actually, right there, the computer vision's doing a better job than I was. Let's just let it do its thing. Oh, right as I say that, it starts oscillating. Alright. Oh, yeah. What a good cat. Okay. What are we doing here? So this is the output of the left side of the flip-flop, it looks like. So this flip-flop is what I'm trying to use as basically the left, the sixth state here. So these two chips are both count to N. Pin 1 is a clock input, pin 2 is a reset, then all the other pins are states. There's kind of an implicit 0th state that they go into right after reset where none of the outputs are high. And then after the first clock, the first output goes high, then the second output, the third, etc. And then it gets stuck with the last output high, even after you give it more clock cycles. So this is like kind of a ham-fisted attempt at daisy chaining these two chips together. I really should have thought this through better. But this is the first chip. You'll notice the resets aren't connected because I reset them manually with a NOT gate, and I've just been reverting to the save every time I try this. Because I started running out of parts. Like, I had to start sealing nodes from my reset circuit, cannibalizing nodes for the rest of this. So, like, really, it's a sign that my general approach is breaking down and that I really should rethink this. But I feel like I could almost get this working, so I'm going to keep trying this approach a little more. Maybe I'll tear it all up and try something different, but I feel so close. These circuits over here, I added kind of at the last minute to kind of slow down the process of thrusting. Well, on your screen it would be that direction. I guess I really should mirror that so that I can point in the matching directions, but I feel like watching people's mirror person is super weird. It's like people look completely different if you swap them horizontally. At least that's my experience. So I feel like that would be disingenuous to be showing you all my mirror self instead of my real self. Oh, cool. Got hi from Ukraine as well, from Tetracl7, I think. Cool. I was having trouble reading it because the font is so small from here. Maybe I should see an optometrist. Let's see. So this is the. So what are we doing here? So it's supposed to stay put until clock cycle 5, and we're thrusting left on the screen into the button 5. Then we've got to immediately get off of it. So I think we're thrusting maybe right and up on the next cycle, on 6. How did I do this? So this is 5, 5. Yeah, 5 is thrusting left, which is what we want. Then, okay, yeah, 6 is the clock cycle I'm messing up here. So I think it would be sufficient to just go right. Right? Like if I go up, I'm going to overshoot, and if I go right, I'm not going to have any problems. So I want to go right on clock cycle 6. So clock cycle 6 is what the left side of this flip-flop is being used for effectively. So that seems right. It's kind of hard to see what that wiring is, so let's just rewire that just to check, but that looks right. Like, I think I just disconnected that, and that's the same thing. So the left side of that flip-flop is state 6. Oh, never mind. I was just really tired when I was working on this last night. This is the same problem we had in one of the other robots. The problem is I need this to have an edge detector because this output stays high forever, which is good in this case because I'm gating the clock and allowing this chip to take over and handle the remaining clock cycles. But in this case, I actually only wanted to temporarily switch this into the left state because on this clock cycle, which is, I don't know, what is that, like clock cycle 7, I flip it right back into the next state, which seems right. So I think I just need to add an edge detector here, and then that'll fix this bug. Oh gosh, I'm out of nodes. Am I gonna have to use another bus chip as a node? Do I have any more bus chips? Is that what I was doing? No, these are both count to N. Oh gosh, am I gonna run out of chips too? That's a bus chip. These are count to N. I mean, I'm not low on gates, but let's put that back. Oh gosh. That's the clock. Oh, and we can't make a clock without a node either. Yeah, I think this is not only too messy, but actually just getting too big for the game's limits. Unless we can optimize this somehow. in a small way, I think it's time for a redesign. So the thing where I'm dealing with that crossover between the two pulse chips is a huge problem. If I could insert the delay using one pulse chip, and then like basically move that discontinuity somewhere where it's not going to be a problem, I think I'll be having a better time. The top two robots are fine, actually. Like, this circuit is fine. I mean, the main thing that I'm imagining the redesign would do is maybe, like, abstract the problem a bit, make a chip in the innovation lab, bring the chip in here, but, I don't know. Actually, like, mostly this problem is about counting steps, and we already have this chip that does that. Unless I could make a slightly larger one that doesn't have a reset, but that's a weird optimization. Wait, this is just a node chip, right? And this is just a ring oscillator. In fact, these are two ring oscillators. I could load this with a clock. Oh, I could save two chips. Let's make the clock in Sparky. Okay, so the clock can go in any robot. It doesn't matter which robot the clock is in. So we're using the third output on the clock. There are four pairs of clocks at 4 different speeds. So we're using the third speed. Oh, this is good. So let's put this in here. Wire it back up the same way. Now, each of these circuits can be replaced by one of those first two outputs, and it'll be the same. So that goes up here to this AND gate. I'm using these oscillators to slow down thruster movement, just by pulsing the thrusters. And then this circuit's the same deal. What is going on here? Oh wait, no, this is not a ring oscillator. This is an edge detector. Sorry, this is what I'm trying to build in the other robot. That was still helpful though. I mean, I could also maybe use a chip to do this job in the other robot, but I think by saving that node, I think I might be all right. So this combination of, this is the input signal. This is all really hard to see because I used the wrong directional gates here because I was lazy when I built it. This is the incoming signal coming into this node. It goes to one input of the AND gate, and it goes to this NOT gate. And then the NOT gate goes to the other input of the AND gate, which then goes to the left side of the flip-flop. So that means when this signal goes from low to high, for one clock cycle, a pulse will get through this AND gate before it gets shut off by this NOT gate. And that'll be long enough to flip the flip-flop. But then when the corresponding pulse comes in on this counter chip, it'll flip the flip-flop back. I think chip 6 is a node, or a bus chip, which I'm only using to split the signal in one direction, so I could also easily save a chip there, but right now I'm more worried about nodes than chips, so... jeez. Now, I think the node constraint is... I don't know how much of that is gameplay and how much of it is engine limitations. The engine does have a limit on the maximum size for one net, so one, like all the wires that are connected together, which is, I think, is around 15. I don't know exactly. Oh, what is this? Oh, I'm not using this node anymore. This is like dead code. That can just go directly to this thruster. That's great. I think, unless I'm making another mistake. Okay. Let's put a node here instead of the chip, because it'll be a little faster. I don't know that that really matters, because everything here is much slower than the single cycle propagation delays. This will be a spare chip. I've got one node, which I think is enough to build that edge detector circuit over here. This game has a bug where if you pick up something from the toolbox, it'll often actually take the item out of the toolbox, but then grab just something different. I've just been starting to get used to that. Okay. So this... So split it to both one of the inputs on the AND gate and that NOT gate. Okay. Let's see if that helped. I think that'll fix that bug, but there might be other bugs. So let's let it autosave and try this out. Oh, I broke my right thruster. Oh, that's right. I think that clock cycle is actually short, and I need to reset the flip-flop one cycle later. That was really close, though. I think I know how to fix that. That was this signal coming from this pin. I think it needs to come from, oh, this pin. Jeez, do I need another node? Maybe this is what I need that node, the bus chip for. Yeah, let's bring the bus chip over there. Am I gonna use everything in this puzzle? This really does start feeling like working on a live circuit with a tiny soldering iron, just given how cluttered things get in these schematics. It's an interesting experience, and I'm less frustrated with it now that it isn't so much like tedious keyboard twiddling. The trackball's a little nicer on the hands. Okay, so I could wire this chip up here, but instead I'm going to wire it up to where that node was and reclaim my node. I'm going down and right. Yes, so 6 was right against the wall, and then I'm going to go down and just slightly to the left, which is why this has the slowdown kind of circuit there. This is messy again. Let's hook that up from the other direction. Oh, saved a precious node. Alright, let's try this again. Take a full-size save this time. I'm feeling lucky. Alright. Oh, the robots were doing great, and then I just had to go in and do my part. I was like sure that it wasn't gonna work, but it actually worked. Okay, sorry robots, I was falling down on the job there. Okay, let's try that again. Where's Tuco? I don't know where Tuco is right now. 7, 8. Oh my gosh, and there's the teleporter. Yeah. Okay, I don't know about you. I'm taking these robots with me home, because, you know, I think they're cool. I think we bonded through this experience. Feeling good about that full-size save I did. That was a good move. That was the save I want. Alright guys, good job. Guys, what pronoun do robots use anyway? Pretty sure I'm anthropomorphizing them too much because I knew these in my childhood. Oh yeah, and you. I barely knew you, Master Computer, and you have such a simple circuit. And you're also so much easier to walk into for some reason. That's gotta be a bug or something. Alright, let's turn off the clock. We don't need to be beeping as we re-enter civilization. Alright, bots. Are we ready? We did it! We escaped Robotropolis. We are one of the few true robot masters. Yes, I've seen this screen before, but only because I was testing the game. This is the first time I've seen it via legitimately actually playing through from start to finish. So, yeah, that was fun. What a weird game. There are definitely parts of it where I feel like there just could have been better game design happening. So, like, some of the puzzles are just not good puzzles. Like but I don't know, in hindsight, they had some upsides, right? Like, I was cursing the dark maze the entire time, and I got so close to cheating in the dark maze. But, you know, then I drew it out, and then it was actually kind of an interesting experience, like feeling my way around this maze, and then drawing it out on paper, and then using that to get through it. And then we cheated afterwards just to look at it, which was fun. But then I didn't use that save file in this playthrough. So, yeah. That was neat. We made some good chips. We made that cycler robot communication chip that helped us out in several of those puzzles, but tried a couple different approaches. Yeah, that was fun. Well, thanks for joining me, those of you who joined me on the stream. I'll get these segments edited together into something contiguous for YouTube for folks who just want to see what it's like to play this game. And if you want to try it yourself, there are a bunch of ways to do that since this game was released on Apple II, DOS, and Tandy Color Computer. I would not recommend the Color Computer version. I've only seen it in YouTube playthroughs, and it looks like it was really stripped down because they didn't have as much memory, I think. And the Apple II version and the DOS version both seem pretty good. I grew up with the DOS version, which is why that's what I ported, but a lot of people like the Apple II version. It looks significantly different. but I think it mostly is the same gameplay, just with adapted graphics for the different graphics limitations. So I don't know why I bothered cleaning up my robots to take that teleporter, because you can't save the game after you board the teleporter. So like that last save is really the last one that's worth keeping. But yeah, I hope you enjoyed that. And I'll be back with other projects. I've got, as you might notice, a couple of things that came in the mail that we need to dig into. I've got all the usual ongoing reverse engineering and engineering projects. We've got the cat camera, which you've been seeing, but needs some more development work. But yeah, well, it turned out that was actually a pretty short stream. We were really close to beating this game, and we beat it, so there we go. Maybe this is a good time to like answer questions, since I feel like I've got some energy for streaming still. We could either just like mess around with editing the game's data files, or just like chat or something. One thing I was playing around with recently was using the console to look at all the rooms in the world and find stuff that the game wasn't really using. So let's see, there are a bunch of ways to do this. There's a reference you might find handy if you go to the GitHub for this port. The source directory, there's this header file, rodata.h, which documents a lot of the in-game data structures. This is the one we're most interested in right now, which I've been calling ro-world. This is like the main data heap for, like, in hindsight, after getting more context for all this stuff, I think what's going on here is that this is all based on an animation tool that Warren Rabinett wrote, based on his experience with the Atari 2600 Adventure. And that animation tool was then extended and adapted to create several games, including this and Gertrude's Secrets and Rocky's Boots. And then the animation engine was ported to DOS at some point. And so this game kind of has two layers. There's the actual animation engine itself, and then there's all the robot-related stuff that they put on top of it. So RO World is actually just the animation engine. So nothing in here is really Robot Odyssey specific. So I would expect to find a very similar data structure in any of the games based on that same engine. So you can see it has parallel arrays for all the sprite attributes. Sprites have a room, a color, a location, or sorry, these are objects, not sprites. There are 256 objects and 64 sprites. So you have 256 different instances of a thing in the level somewhere. Some of these, because the sprites are limited in size, some of the larger things, like the big chip or the robots, are actually multiple linked objects. The objects can be linked together. I think, is that what this grab flag is for? Object list head. There are several linked lists in here which let it track which objects are in the same room as other objects and which objects are grabbing other objects. Oh, moved by, that's what I'm looking for. So yeah, objects can all be moved by another object. So like when the player is holding something, when a robot's holding something, that's how it works. Objects have these single color sprites, and each level has up to 64 of those that defined. So anyway, I've annotated these with memory addresses here. There's also this data structure I've been calling RO circuit, which seems to have all the game-specific stuff. So it starts out with electrical wires, but then it also has a bunch of flags, which I haven't really documented much. In fact, I think some of this might be wrong because, like, Toolbox is closed. I tried that in the tutorials and it didn't have any effect. I think maybe the address is different depending on which binary you're in. That's a little frustrating. But then there's robot state. There's a separate data structure for grabber state and for battery. The batteries have like an 8-bit value in the robot data structure, but then there's a 16-bit accumulator that actually has like a more detailed tally of the battery state. So if you wanted to get a much better idea of how much energy different things use in the robots, you could be looking at the rate that these accumulators change at. Oh, and to Trasiel. So, and I saw your question about what other projects I have. Yeah, we can get to that soon. I've got, I think I mentioned a few of them while I was rambling earlier, but, oh geez, I'm just looking at the mess behind me. What projects do I have going on? The big one that I've been doing recently is this thing called Tuco Flyer, which is this remote control slash Tuco vision, or slash computer vision slash interactive camera. Oh, he's on the couch there. Yeah, let's get a good view of him. So I've got this camera that I've been working on. I've also just been doing a lot of reverse engineering and teardowns lately. My primary thing that I've been doing lately has been trying to figure out how to produce like interesting video content that helps people get inspired and learn about like customizing and understanding and like making the devices around them like more their own. So I don't know, to be honest, I have a hard time defining like actually what it is I do here, and I've been able to spend so much time doing it, I think partly just because of momentum. Like I spent a lot of time doing this as a kid and I got a lot of experience with it, and I put a lot of projects out on the internet that people liked, and then I got this base of, I guess, fans and supporters like you, and I feel really lucky to now be in a position where I can spend a lot of time like sharing this sort of intricate side of the insides of computers and electronics and games and whatever. But it has been a bit eclectic, and I do struggle to figure out what I'm actually doing here sometimes. So I also need to sneeze or something. Sorry, I'll be right back. Alright. I feel like I should save this save game in my notes before I lose it, like my winning solution to this puzzle. Let's load that last full-size save. Which was this one. I've been mostly keeping track of my save games via just like copy and pasting these autosave URLs. I just need to... Sometimes it's hard to disengage mouse controls. Oh, right, we had that huge big room up there for testing, which I didn't use at all. That would have been smart, though. That was just so ominous. I just did all my development right here on the transporter. All right. Messy solution. So yeah. So we can start poking around with this memory. One thing that I've been doing, which you might have noticed in my notes just there, was exploring the other levels in the data file. We also used this in the last stream for our aside that we took after going through the dark maze to turn on the lights and see what it actually looked like after the fact. Aw. Well, thanks for the kind words in chat. So you can see right here I'm editing this location OX300 in the world. So let's first do the same thing where I'm making an alias to world just for convenience. So now I have this data structure. So the player, so aka the cursor, whatever you want to call this little creature here, that's object 0. So if we just use like the first address in the data table, we get the attribute for the player. So 300, for example, would be the room that the player's in. 400 and 500 would be the player's x and y coordinate. So for example, we could just like move the player around if we wanted to. We could even put that kind of thing on a JavaScript timer just to have the player continuously scoot around the screen if we wanted to be mean. Or if we wanted a more cheaty version of the mouse controls, we could have one that actually just sets the player location instead of inserting joystick input. We can also change the room number. This doesn't entirely work correctly because if I just modify it here, I'm not updating any of the linked lists, so the objects won't actually show up correctly, nor will anything really be grabbable, I think. But it is enough to actually change what the rendering engine on the game displays. So we can use this as a quick way to page through the rooms in the game and see what's available. So this is room 42. Is that right? I think there are 64 rooms. Well, 63. Sort of 62. Rooms 0 and 63 are both kind of weird. 0... Sometimes 0 displays nothing. I've been having 0 crash the game. I think 0 is actually a modal dialog box of some sort, and it might be revealing some unpatched infinite loops in the game. So it's either that or it's actually just an infinite loop in one of those linked lists. So 0 is kind of a crash in a lot of these game levels, but 1 is a safe place to start. 1 is actually the help text as a room. Let's do pre-increment so we can see what the room is currently. So this is like the first room. These are all places we've been. That's one of the Frogger levels. Oh, just setting the room to the Frogger level activates the trap there. So these are actually several different similar Frogger levels. And then we actually have rooms that represent the insides of the robots. More Frogger levels, more robots, puzzles. Here's a dark room. And so if this could be empty or it could be black on black. So I could try that same trick from earlier to change the foreground color. So, I was using W300 to get the current room, and then using that to index into the room foreground color table, which is at E80. And so this will tell me the foreground color of the current room. 6. I don't remember what any of the colors are. Let's just increment it. I think this room is empty. Okay. More empty rooms, I guess. If we wanted to actually edit the blocks in the room to see what that looks like, that's stored down here in room tiles, which starts at OX 1000 hex, 4 kilobytes. And each room is actually 30 bytes. The room format is pretty weird. Each byte is a 2x4 block, and each nibble within the byte is one of those vertical columns. And then it goes top to bottom, left to right across the screen. So it's 10 bytes, 10 bytes, 10 bytes, and then the whole room is 30 bytes. So the room table itself is at OX 1000, and then we need to add the current room number again if we want to do this to the current room. And then the rooms are 30 bytes long. So the first byte in the room is 0. If we wanted to just fill that in completely. Yeah, so that room's just empty. This is that pattern I was talking about. Just to show you how these bits are mapped. There's 0. Oops. There's the least significant bit. And the most significant bit. It's pretty simple. Next room. A lot of empty rooms here. Deactivate guard switch. So there's a lot of room actually to just add your own content to the game if you wanted to modify it. Like I've toyed with the idea of having a level editor for this. Like it wouldn't be that hard to make a thing written in JavaScript that you could just kind of add on to the game via this interface and make a level editor. It's not drawing the robots because I must have just messed up the linked list by hitting all those traps while the world data was corrupted, basically. Oh, here's... Huh. It's the discotheque. Oh! I don't remember this screen. Did I accidentally remove this? I mean, I've been removing the like insert disk whatever screens, but I don't think I would have known that this was an insert disk whatever screen just from looking at the disassembly. Because those look very different. There's like a draw modal dialog box kind of function in the code, and you pass it a string. Whereas if it used this, it would have looked like set the room to this, then stay in the main loop. Whereas it did not stay in the main loop. It stays in a modal. So I wonder if this is actually left over from the Apple II version. This might be the Apple II disk change screen before the end of the game. Now that I know this is here, it actually might be worth editing the port so that I show just the congratulations portion of this briefly. But that seems kind of superfluous because like the cutscene and the animation that's there already work pretty well. So yeah, I think this is left over from the Apple version, but correct me if I'm wrong, if anybody else knows better. Here's another disk screen. This is the junk room. Usually room 63. Even though, as far as I can tell, there's actually space allocated for this. Like, we could draw in room 63. Yeah, that's drawing in room 63. But usually this is used as like a null kind of value. This game is not that efficient with how it uses memory. Like, it's constrained by memory in a lot of ways, but it could also be getting a lot more out of the memory that it has, so... I think a lot of it was just limited by the development time and resources and the tools they had probably, rather than like just the amount of memory. Anyway, there's not been much in this world. Let's see if there's anything else to look at in one of these other worlds. Let's consolidate these save files. Let's try World 4, see if there's anything interesting in there. Oh yeah, this is the Master Computer Center, which is kind of an interesting level on its own. This is where the puzzles start to get really hard. Since I switched levels, I should get a new world pointer, because the different binaries might have different load addresses. In this case, I think it's the same binary, so I don't think it'll actually be different, but it couldn't hurt. So this is room 29. Room 1 is again some help text, but when the help text is actually being displayed, it doesn't have the camera in the corner, so they must be using a different display loop to actually show the help text. Got the elevator and some hallways. That was the garbage bot going by. Here's the inside of a robot. More hallways and robots. That was a ventilation shaft maze piece. There's the library. More hallways. That's the center. That's the map room. That was the minefield. I think I'm crashing the game by putting the player in the minefield. the game has plenty of places where if the world data is incorrect, it'll just go into an infinite loop. I've been thinking about maybe fixing some of those. Let's start at the other end. Let's go to the last room. Go to that junk room, maybe. Here's the junk room in the computer center. That's funny. So this has some extra walls and stuff too. Are these extra pieces of text, or is this pointing to existing pieces of text? There's so much going on that it's kind of hard to see. Some of these pieces of text are familiar. It might just be drawing all the text when the current room is set to no room. That might just be how the text drawing works. I don't know that much about the text drawing engine. High voltage room, maze parts, ventilation shaft parts. Oh, we just got warped there. Yeah, so this is a little hard to do with the game's full-on main loop running. There might be a better way to do this running just a rendering loop and not running the actual game logic. Like, we could probably pretty easily figure out which function in the game is just draw the room with this number. Actually, it probably doesn't work like that. It probably is... I mean, this game extensively uses global variables, so all the drawing functions are probably just checking the same value, but there are probably single functions we can call to just draw a specific part to the room. So like just draw the playfield, just draw some sprites. There's probably a function that's been added to this level's main loop that's drawing the security cameras. And so as long as the security camera's on the screen, we know that we're in that main loop and not a different main loop. Stuff like that. I don't know, anything else you guys want to see? Because ladies and gentlemen, I think that might be a wrap for this game. Check out chat again soon. Oh yeah, that's a good, got a lot of good things in chat, actually. Yeah, good suggestion for making some more sort of beginner content that's, because like, I realize, and Alan has pointed out that this stuff can be pretty hard to follow because we're often starting a stream just like deep inside of something. And yeah, no, totally, I mean, this is pretty raw, and when I edit this stuff into completed videos over at my video blog, which I know I end up putting out a lot more live content these days than the edited stuff, because the edited stuff takes so long to produce. But I produce these edited videos that actually do, I think, try to give you the prerequisites. Like, especially this one, I think I was trying to actually give you the information you need to understand what's going on, and not just like throw you in the deep end. But yeah, the live content is much more just like raw in the deep end. And I have some plans for more like specifically focused introductions to a topic. And so Alan was suggesting robots, and that would be cool. I've also thought about doing more of an introduction to USB, and I've been like working on some content for the first episode for that. Because USB is one thing that I really enjoy. I mean, okay, that sounded perverted. Sorry. I've really enjoyed making objects, like microcontroller-based devices that communicate over USB, and I think it's an underappreciated communication medium, and I've appreciated the details of it for a long time, so I think it would be interesting to share those with people. So that's what I mean. Oh, and Alan's was also wondering how I learned this stuff. I mean, it's just a lot of time. I mean, I keep trying to. I think a lot of what I'm trying to share with people by showing you showing you all the process is, so much of this is just about like patience and time and stubbornness and I mean in a lot of cases like access to time and materials, but patience. Yeah, I mean, I don't know, like a lot of reverse engineering I think is just being willing to spend more time looking at something than I think most people would find reasonable. And then, obviously skills build up over time and you get more familiar with things, but that's just because I've been doing this for a long time. I've been curious about how things worked and taking them apart and trying to build my own stuff ever since I was like 6 years old. And I'm like 35 now. What year is it? So yeah. No, 34. 33, one of those years. What year is it anyway? You all don't need to know exactly how old I am, but I'm in my early 30s, and this game was made approximately when I was born. So that's kind of the context. And then I started learning this stuff. When I was a kid, my dad would bring home a computer that he used for work, and he spent some time teaching me the basics of like how to open like BASIC and read the manual, and we wrote a couple of simple programs together, and then I pretty much like used that computer and tried to learn stuff anytime I could, and that was when I got started. But some people get started early, some people get started late. Like, I think a lot of it just depends on how enthusiastic you are for the details and how much patience you have for just kind of slogging through the boring parts in a lot of cases. So yeah, well, I think I might just quit while I'm ahead and keep this stream short. And if you want to try this game out, you can try out this port. It's just robotodyssey.online. The source code for my port is over here at Robot Odyssey Rewired on GitHub. Yeah, and like this is all open source. Like, you can compile it and modify it yourself. If there's stuff you want to change, feel free to send me pull requests. I'm more interested in pull requests than issues, but if there's like gameplay issues that you want to document, sorry, I didn't mean to start the beeping. If there's gameplay issues you want to document, feel free to file issues, but like don't necessarily expect that I'm going to be attentive to them, because this is just like a random side project, like an homage to a game I liked. But if you have actual code changes and you have a pull request, then those I will be usually happy to commit if the code is good, or if there are problems, we'll talk about it. But yeah. And then it's just up here so that it's convenient for people to play. Like, obviously this is not my game and I don't own the rights to it, so it's like basically up here as abandonware. And if I ever hear from the people who own this game, then I'll be happy to take this down or like let them host it with my code or whatever. But for the moment, this game is basically abandoned, and the original authors have no stake in it, and the people who currently own the copyright are really difficult to track down, so I've just been hosting it here if you want to try it out. So that's where it is. And so you can go through the game. The controls work pretty much as the original game would have. One thing that's kind of weird currently is how you load and save chips. So if you're in the Innovation Lab, you can pick up a chip and press S to save it, just like you would have in the original game. This gives you a download. But if you want to load a chip, it's a little bit weird. Like, pressing L holding the chip doesn't give you a menu right now. It just loads whatever file is in an internal buffer, which is really non-intuitive, and if you don't have a good piece of chip data in that buffer, will crash the game. So you do have to hit load file down here, pick a chip, like Stereo, for example, which is one of the built-in chips, and then you can press L. and then you can press slash to see what's in the datasheet, and it's there. That's like one gotcha in the current port, but like I plan to fix that, I just don't know when, because that kind of requires more like UI around all of this than currently exists. And then there's mouse controls. By default, the mouse controls are not enabled, so you just like move the mouse over the game, it doesn't do anything. But if you click once, it unlocks the mouse control and it follows. You can go inside, you can go outside. If you click, from then on, it just acts like pressing the joystick button. So dragging is not really useful because dragging with the joystick button down in this game was not very useful. But clicking is sort of like picking up or putting down an object. Got spooked by that noise. That's the UPS's self-test. There's also a little bit of queuing, so you can do a series of actions without really waiting for it. Just a little bit of queuing. I didn't want to make the queue too long because that can be really unintuitive if it's doing a bunch of stuff and you don't know how to get it to stop. So you can get just very slightly ahead of the game, but not that far ahead. But by doing that, you can basically do frame perfect, like moving and like if you can click on things in sequence with pixel accuracy and then just wait for the game to catch up, then what that'll do is it'll spend every frame during the move moving to the object, then spend one frame clicking, one frame unclicking, then spend all the next frames moving to the next target. So you can do pretty efficient movement that way. And you can also crank up the speed, which is especially useful if you just want to wire a circuit. And then you can just like move stuff around without really having to wait for the game at all. And then, you know, test circuits. That would have been more interesting if they were OR gates, but you get the idea. And then, you know, for example, if I built a chip and I wanted to save that, let's just make a really terrible chip. All right, this is a terrible chip, but you could. That sound effect is a little weird in 10x speed. Normally it sounds more like this. Then you can edit the data sheet. So we could just have a data sheet for some awful chip, and then press S, and then it downloads that file. And if we look at that file, it's a .csv file, which I didn't choose that extension. The game always called these CSV files. It does not stand for comma separated value. It stands for chip save. If we sort these by time, you can see the one that I just saved. It included the name, my terrible chippo. So you can see the ASCII text at the bottom for the datasheet. This is bytecode space for the actual contents of the chip. And this is pin states at the beginning. I did a blog post a while ago with a decompiler for these chips, which might be fun to integrate into this port at some point. Anyway, and then let's say we wanted to load that just to illustrate. In fact, it's a little tough to tell what's currently in the buffer, and after saving a chip, that chip that we just saved will be in the buffer. So, like, it can't hurt to load a different chip if you just want to be sure that the buffer is different. Oh, why didn't that load? I thought I loaded stereo. Yeah, this UI clearly needs work. I don't know why that one's still in the buffer. What about RS flop? Okay, yeah, that was the bug that I was actually just avoiding. If you select the same file twice, it doesn't actually load the file again because I'm using the HTML5 onChange event for a file picker. That just feels like something that needs fixing, but it's like a bug I've been tiptoeing around so far, which is unfortunate. Anyway, I think that's enough rambling for the moment. I'm gonna take off, but I hope you enjoyed that. Hope the end of Robot Odyssey was interesting. Let's watch that final cutscene again, just for fun. This is that last save before the end of the game. This will be for the folks who just seek to the end of this stream expecting that that's where the end was. No, it didn't take us that long to solve this, and then I spent a bunch of time rambling. That's fine. So I've got to hit the remote and the starter at about the same time. I think I want to hit the starter a little bit before the remote. And then I want to run down, and then after Sparky hits 8, I've got to hit the last button. That's it. So starter, remote. I can get in position. Robots do their dance with their awful messy circuit. Alright. When I did this as part of my actual Let's Play, I was careful to take the robots with me, but since it doesn't actually matter, just for the sake of seeing the cutscene, let's stand on the teleporter. Bye, bots. See you later. Was it all a dream? We'll never know. This does feel like the dream of some... You know, I can imagine this being like some almost like cliche Silicon Valley tech nerd dream that's like, you know, you fall into this terrible underground pit in your pajamas and you have nothing to escape, but you have all the time you want to just like design circuits and fabricate custom chips and test them. That does seem like a dream, doesn't it? So yeah. You might wonder what it would be like to actually save the game on this screen and what that looks like, but it wouldn't really be like, this is not running the same engine. At the point where you stand on the teleporter and finish the teleporter animation, it's actually switching to a different exe file, and this is actually an exe file that we're not using anywhere else called menu2.exe, which has a second copy of the main menu, which is used on the second disk, but it's also just where they had the free space to store the end cutscene, so it lives in there. They obfuscated it slightly by calling the binary with a strange command line argument. It's like a control code OX17, I think. So, in fact, RO engine exec. This is like what you would type in DOSBox if you were playing this. You'd start with play.exe, and it would open up this. Play.exe is actually a launcher from menu.exe, which just does this. You can tell menu to go directly to the menu by giving it this command line option, which is what play.exe does on the way back from a game. And then there's menu2. Or sorry, just for reference, like the game itself is game.exe. There's also lab.exe, which I think will crash actually if you run it without a command line option. Or will it? No, it just doesn't start. Normally you have to give these a command line option indicating which level to load. The lab also is responsible for that chip design tutorial. So you cannot jump directly to game levels past the sewer because those files are not included in this package. There's like a different file format for an entire game level and an overlay that gets loaded as you move from level to level. And this package that the game shipped with only included those overlay files, but I'm guessing that for development they also had files that let you start on a particular level. Let's see. So then if you run menu2.exe, Normally, this would go to the main menu. I'm expecting this to do nothing, or to go back to play.exe though, because I modified this to save a little bit of code space. Oh, it crashed. Okay, that's fine too. I just inserted a return instruction there, and I think it returned somewhere bad, but I'm not really concerned because that's basically dead code that I was just trying to eliminate to save space. But then if you actually just call menu with this weird hex control code, I think that'll start the cutscene. Yeah. So that's what it actually does when you step on the transporter. And then this is just an infinite loop. I broke the infinite loop with the JavaScript callback, so it doesn't actually hang the browser, but it's still an infinite loop. So. All right, well, that's all I got. Thanks for joining, everyone. And congratulations if you too have beat Robot Odyssey. If not, then, well, maybe you enjoyed watching me play it. Maybe you would enjoy playing it. If you want to try it out, then you can try out this port. You could also play it on an Apple II emulator. It doesn't really work in DOSBox that well on its own, but there's a binary patch I made for it a while ago, which you can Google for. And if you patch the game, the patched version will run in DOSBox, but the regular version will not be playable because of a bunch of changes in the way PCs work in the last several decades. So, anyway, thanks for joining. See you next time.